Let's look at this problem. There is this bullet-like solid, and its shape is given by this equation, and we need to determine the radius of gyration kx of this body with respect to the x-axis. So if you remember how to calculate that, so Ix will simply equal to the total mass m times kx squared. Therefore, kx will equal to the square root of Ix over m. So we're given the specific weight of the material, which is 380 pounds per foot cube. In this problem, we actually do not need that because we're going to calculate kx. But if you need to calculate Ix instead, if you actually need to determine the value of Ix, then you do need this specific weight information, and you can convert between that to density. So specific weight is weight per volume, and density is mass per volume. So as you can probably tell, rho will equal to gamma divided by gravitational constant, which is 32.2 foot per second squared in the US customer unit system. Therefore, in that way, this rho density will have the unit of slug over cubic foot, and that will be the density in the US customer unit system. And from density, m equals to rho times v, and in that case the m mass will have the unit of slug if such calculation is necessary. Now coming back to this body, if this body is made with these type of a thin plate, one after another, then because all of these thin plates share the same x-axis that passes through their center of gravity, therefore the total Ix will simply equal to the summation of the smaller Ix add together, of all these add together. However, when the thickness of this thin plate is small enough, this becomes actually the integration throughout the body of small dix. Now, if we choose one of these thin plate as our differential element, okay, so this x-axis passes through its center of gravity right here. So we can look up the formula either on the internet or from your book. We can tell that this dix for this thin plate can be evaluated as 1/2 r squared times dm. dm obviously is its total mass, and r squared, this r is its radius. So in our case, this is actually 1/2 y squared dm. Therefore, our Ix equals to the integration of 1/2 y squared dm integrated throughout the body, but dm equals to rho times dv, which equals to, so dm equals to rho density times dv. And what is the volume of the thin plate? This equals to area times dx, the thickness. The thickness is dx because it's along the x-axis, and its area is calculated as the area of the circle, which is pi r squared dx. And in this case, the radius is y. This equals to rho times pi times y squared dx. Therefore, our dm, so everything else stays the same, but dm becomes rho times pi times y squared dx. So now this is the integration with respect to x. It integrates from 0 inch to 8 inch. Now, pull out all the constants. So 1/2 rho times pi are constants. So we're left with y to the 4th power dx. But don't forget, y to the 3rd power equals to x. Therefore, y to the 4th power equals to x raised to the 3rd power dx from 0 to 8. And this becomes 1/2 rho times pi times, do the integration, 3/7 times x to the 7/3 power, evaluated from 0 to 8. Therefore, this equals to 1/2 rho times pi times 3/7 times 8 raised to the 7/3 power. So at this point, if you are curious what the unit of this would be, well, the unit of this will actually be slug inch squared. It's mass times length squared. Okay, so the unit actually at this point does not matter as long as we are consistent. So don't forget, we're trying to find kx. Kx equals to ix over m square root. And m equals to integration throughout the body dm. We have already determined that dm equals to rho pi y squared dx. Therefore, this becomes rho times pi times y squared dx. But again, because y to the 3rd power equals to x, therefore y squared equals to x to the 3rd power dx. Again, integrated from 0 to 8. So this becomes rho times pi times 3/5 x 5/3 power, evaluated from 0 to 8. So this becomes rho times pi times 3/5 times 8 5/3 power. This is in the unit of slug, by the way. Therefore, now our kx equals to square root of ix over m. And if you compare these two expressions, you realize that many constants can be canceled out. This can be canceled out. Therefore, what's left is going to be 1/2 times 3/7 times 8 raised to the 7/3 power, which is the same as 2 raised to the 7th power, because 8 cubic root is 2. This is actually 2 raised to the 7th power, because 8 cubic root is 2. Therefore, 8 raised to the 7/3 power equals to 2 to the 7th power. So on the denominator, we have 3/5 times 8 to the 5/3 power, which is also the same as 2 to the 5th power. So evaluate this square root. This equals to the square root of 1.43, which equals to 1.20 in the unit of inch. And that's the answer to this problem.